fellow Toastmasters and guests. Man has long since struggled to understand the workings of the universe. Ancient Greeks, Egyptians thought that the answer lay in mythologies about magic and gods. Then came a string of Muslim scientists in the Middle Ages who expanded our horizons literally and helped us understand the workings of our world much better. After that came scientists like Galileo and Copernicus, who stared heavenward and further expanded our understanding. Then came Newton, who set it all aside with his laws of gravitation and laws of thermodynamics. But that's the trouble with science, and that's the trouble with knowledge. It's never enough. So it was up to Einstein to once again redefine everything with his theory of relativity in the early 20th century. But no, my project is not about theory of relativity. My project is about the theory that succeeded it, quantum mechanics. Say goodbye to your sanity, because I did when I studied quantum mechanics, and I'd like all of you to join me in the madhouse. See, what's the difference? The quantum mechanics describes the behavior of matter, energy, space and time at a subatomic level. And I guarantee that a simple experiment will help you understand the founding principles of quantum mechanics. But first, please understand that light, as we see it, is made up of photons. And photons are particles, and photons are also waves. Don't ask me how, ask one made it all. But please understand that. With that, who has heard of the double slit experiment? That's good. It was an experiment performed by a British physicist called Thomas Young in 1801. And it was quite simple initially. He placed a source of light behind a board containing two slits. The light crossed those two slits and made a pattern. How that pattern was formed? Remember, light is a wave. So waves, when it hit the slits, it split into two. And then those two splitted waves came back and met each other. This meeting is called interference. The wave, where they cancelled out each other, there was the patches of darkness, and where they reinforced each other, there were patches of light. With me so far? Next, what will happen if we close off one of the slits? Can anyone tell me?
There will be darkness.
There will be complete
Actually, this will happen. You'll just see a single line because there's nothing to interfere with, right? And if you close off the slits one by one, first you'll see the line on the left and then on the right. There's nothing to interfere with, the photons are passing through just a single slit. Now this is where it begins to get weird. What do you think will happen if the photons were fired at the slits, not in a stream, but one at a time? What do you think will happen? Anyone?
Slide will disappear.
Well, actually, this line should either disappear or this line should be much more spread out. But instead, this happened. An interference pattern, even though the single photon had nothing to interfere with, nothing to cross out, nothing to meet. How was this possible? The explanation is much more shocking than the fact. When the photon approaches the slits, it splits into two. And it passes through both the slits simultaneously and then meets with itself to form an interference pattern. How is this possible? We were talking about just one photon, right? A photon is a photon. No, a photon is a probability, and that's what quantum mechanics is like. Why is it a probability? Because when we see a photon, it's a probability of that photon being there. And since the probability of the photon passing both the slits is 50-50, probability divides itself in half and then meets with each other. And no, this is not fiction, this is science. But things get stranger still. What do you think happened when scientists placed detectors alongside the slits to detect that actually which photon was passing through which slit? Surprise, they got this again. Same conditions, same experiment, one difference. There was a detector. It almost as if the photon saw the detector and decided to act normally and logically. But this is not the end of it. It gets weirder still. This time the detectors were placed after the slits, not before the slits. And still, the result was this. What happened? The photons split into two, crossed the slit, saw the detector and said, "Oh my God, I'm being detected." Reversed time, went back to the source and came through as a single photon. This may sound like science fiction, but this is actually what happened. Since 200 years, this experiment is being repeated with the same results. What's the explanation though? Niels Bohr, one of the leading exponents of quantum mechanics, explained it in terms of probabilities. You're not seeing a photon, you're seeing a probability of a photon, and therefore it splits 50-50 into two and then interferes with itself. And what you see is the result of your setup. It's the result of your observation. Einstein said, "No way, God does not play dice with the universe." He was a staunch believer in God, and till the very end, he could not make peace with quantum mechanics. Because it implied that the universe you saw changed according to who was watching it. But that's a reality. Particles are waves, waves are particles, particles are probabilities, and probabilities depend upon who you ask. That's the fact of quantum mechanics. That's how the universe operates at the level of protons, neutrons, and subatomic particles. So what's the conclusion? For one thing, we don't have a clue after 200 years. We can only posit. And those are the theories that explain this experiment. Over to you, Dr.